Hi everybody. So in this video, we're going to look at correlation and linear regression. If you want to work along with me in this video, you can download a copy of a PDF from my website. I'll leave a link in the description below. So we're given that here are results of a length of y of a spring when loaded with a mass we're calling x. And the data is plotted as a scatter graph here. So we should know from GCSE that the data shows a positive correlation. You can see the upwards trend. So this means we can draw a line of best fit. And this follows the trend of the data, so we have as many points above the line as we do below it. Now for A-level maths, this is called the line of regression. And the line of regression is of the form y is equal to a. This is our constant term of the intercept, plus b. This is our gradient, multiplied by x. Now, when we deal with lines of regression, this x will be our explanatory variable. And the explanatory variable, also called the independent variable, is the variable that we can directly control. So this is the variable which affects the y value. And the y value we call the response variable, also called the dependent variable. And this is the one that we think is being affected. So for instance, the greater the mass we attach to the spring, the greater the length. And for A-level, we're not required to calculate this line of regression. We're given this in the question. So in this question, the line of regression is given as y equals 8.3 plus 0.018x. And it's important that we can interpret each of these values within the context of a question. And this 8.3 would represent the length of a spring when we've got zero mass attached. So when this is 0, all of this will go, and we'll get an extension of 8.3 centimeters. So we'll say the 8.3 represents the length of a spring when no mass is attached. And then the x value, well, this would represent the increase of 0.018 millimeters for every additional gram attached. So you can see that this would be the gradient of the slope. So we'll say the 0.018 represents the increase in length for every additional gram added. And we can use our regression model to predict the extension for any length within our given range. So say for instance we had a mass of 17 grams. Well, the 17 is within our data range between 10.2 and 26.4. So we'll substitute the 17 into our model. Y will be 8.3 plus 0.018 times the 17. And this will give us an extension of 8.606 millimeters. Okay? But we couldn't use our model to work out the length of extension when a mass of 8 grams is added. Because can you see that the 8 grams falls outside of the range of our data collected? This means that we would have to extrapolate, which is something we shouldn't do with models of regression. So we need to say that when x is 8 grams, the model is not suitable as it falls outside the range of the data, and therefore extrapolation would be required. Okay? So that covers the basics of models of regression. Let's try an exam style question. Okay, so in this question, we're told that Sophia is studying the relationship between the amount of fertilizer, F, given in kilograms, added to a field, and the yield of crops, Y, in tons. She tested the fertilizer amounts, ranging from 5 kilograms to 30 kilograms, and found the regression line of Y on F to be 2 plus 0.5 F. Part A, we've been asked to interpret the values of 2 and the 0.5 from this model. For part B, we've been asked to find the predicted yield when 20 grams of fertilizer is used. And then for part C, to explain why it would not be sensible to use a regression equation to calculate the yield of crops when F equals 50. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the solution. Okay, so welcome back if you had a go. So I'm going to draw a quick sketch of what's going on. So we've got the amount of fertilizer. This would be our explanatory variable. So I'll plot this on the x-axis. And then we've got the yield of crops, and this would be our response variable. And we're given a range of data from 5 kilograms to 30 kilograms, which I'll plot from about here to about here. Then we can see that we've got a gradient of 0.5 and an intercept of 2. So I'll sketch a positive gradient, something like this, and we'll have the samples scattered around this line. So for part A, interpret the values of 2 and the 0.5 in this context. Well, if we had no fertilizer added, then the 0.5f would become 0, and we'll be left with 2. So this tells us it's the yield of crops when we have no fertilizer added. So I'll say that the 2 represents the yield of 2 tons when no fertilizer is added. And then the 0.5, well, this is the gradient of this slope. So every time we add 1 more kilogram of fertilizer, we're increasing the yield by 0.5. So I'll say the 0.5 represents an increase of 0.5 tons for every additional kilogram of fertilizer. And then for part B, find the predicted yield when 20 kilograms of fertilizer is used. Well, you can see that the 20 kilograms does fall within our data range, so our model would work. So we'll substitute the 20 into our regression model, and we'll get 2 plus 0.5 lots of 20, and this will give us 12 tons. And then for part C, explain why it would not be sensible to use the regression equation when f is 50, where you can see that 50 falls outside of our range. So we'll say 50 kilograms of fertilizer falls outside of a range of the data collected, and therefore extrapolation would be required. Okay, well, thank you very much for watching. I hope you found that useful. You can download the full lesson and a PDF that accompanies this video from my website, mythmathematics.com. I'll leave a link in the description below.